Hello, in this video we'll be solving problems that can be modeled by linear equations, or what you would call word problems or applications. Now, there are many different types of applications with linear problems or linear equations. The one I'm about ready to show you is just one among many. And again, if this is not enough to help you out through your homework assignment, there are more author videos, and as always you can ask me how to do a problem and I'll try to do one very similar to one you're requesting in the student request videos. So let's begin with this one. So what do? How do we solve an application? Well, there's 4 or 5 steps of how to approach these things. And the steps for solving applied problems. Step 1 is to read the problem carefully, perhaps 2 or 3 times. Many times students will try to read the whole problem one time and then have at it. Sometimes when you're dealing with math and words together, one time is not enough. What I like to do is I read it several times, maybe 2 or 3 times, especially if I'm not understanding what's going on, and then I start breaking the sentences up, one sentence at a time, and deciphering it that way. Pay particular attention to the question being asked, but in order to identify what you're looking for. Okay, so what you do is, what are they asking me? That's what you're going to review. That's what your variable is going to be defined for. Identify any relevant formulas you may be used, like the distance equals rate times time formula, or the area formula of a circle, pi r squared, if you can determine realistic possibilities for that answer. Alrighty? So read it 2 or 3 times, break it up, see if there's a formula you can think of that might help you out with that one. Okay? Second step is to assign the letter, the variable, to represent what you are looking for. And if necessary, express any remaining unknown quantities in terms of this variable. So for example, you might be looking for, or they might be discussing 2 different items, but one is in terms of the other. So for example, if I said, if I was comparing boys to girls in a room, and I'm looking for the number of boys and the number of girls, but I do tell you that there's twice as many girls in the room than boys. So there's a relationship to that, but I don't know either one of them. So I would say, well, let X be the number of boys, because I don't know how many boys there are, but since I know that relationship, then there's 2 times X, or 2X, number of girls in the course. So that's the idea. You try to put one in terms of the other one if you can do that. Alrighty? Step 3, make a list of all the known facts and translate them into mathematical expressions. This is the key, the mathematical expression. These may take the form of an equation or later on an inequality involving the variable. The equation or the inequality, alrighty, is called the model. So when you create the equation based on the expressions that you found, and there will be a relationship that's worded or embedded in the problem, that becomes what you call the model. If possible, draw an appropriate labeled diagram to assist you. Sometimes a table or chart helps. Now what that is basically saying is a picture is worth 1,000 words. So if you can create a visual representation of what is going on, so much the better. Sometimes it's not necessary, sometimes it may not even be possible, but if you can think of it, you can visualize it, draw the picture, and it can stay in your brain a little longer to get you that modeling equation for yourself. Step 4, solve the equation for that variable. So once you've got the model set up, then it's downhill from there on. Usually people can surpass step 3, they can get the rest of the way. Step 4 is the step you want to get to. Solve the equation for the variable and then answer the question. And it's usually using a complete sentence. Okay, so you did say, you can't don't get to the point that says you get down this equation and you got X equals 7. Maybe there's 7 boys in that room and there's 14 girls in that room. You don't just say X equals 7 and be done with it. Okay, because X equals 7 might be the number of boys in the class, that's fine, but you've got to tell me. You can't just leave X equals 7 and circle your answer and move on. You have to say there's 7 boys and 14 girls, and you write it out. Okay, And remember, these are applications, or what we call the word problems. And so your answer needs to be put into words. Okay? So very important on application type problems that are on exams. Step 5, check the answer with the facts in the problem. If it agrees, congratulations. If it does not, you got to try it again. And usually go, well, if I have to try again, what do I start with? You usually start with your equation in step 3. It's probably wrong. So your equation was not represented correctly that you did. And that's where 9 times out of 10 the problem lies. It's usually not within the step 4, the solving. By then, it should be, if you're like, well, I'm pretty sure my step 3 is right. Then go back and check step 4 and see if it works. But initially, when if a mistake is made and the answer does not match, it's probably because of step 3. Okay? All right, let's look at an example here. Now, words are a little small on this one because to get a lot of this on this PowerPoint. So you might want to maximize these. When these things happen in MediaSite, you can maximize the screen to the whole screen. It should be a little tool on the right side that you can actually maximize this if you're having trouble reading it, which I am right now. So, it's talking about investments. It says the total of $18,000 is invested. Some of it in stocks and some of it in bonds. If the amount is invested in bonds is half the amount invested in stocks, how much is invested in each category? Okay, that's the problem. So what do we do? Now remember, what are we talking about? We're talking about stocks and bonds. Maybe you want to read the sentence again to get the finer information again. Okay, so it says the total amount of $18,000 is invested. Some of that in stocks, some of that in bonds. Okay? If the amount invested in bonds is half the amount invested in stocks, so which one's more? Bonds is half the number of stocks, so stocks is more. So how much is invested in each category? All right, let's look at the solution here. Step 1, determine what you are looking for. We are being asked to find the amount of 2 investments. The amounts must total $18,000, right? Because you got 2 investments going into one account, which of $18,000. All right, step 2, assign a variable. Okay, assign a variable to represent what you're looking for. All right, so let X be the amount invested in stocks. Okay, why can't you do it in bonds? You could, but you got to find that relationship. So if X is the amount of stocks and what we did in bonds was half that amount, so what does it say, half? Yeah, the amount is half. Yeah, so, and then 18,000 minus X is the amount invested in bonds. All righty, whatever's left. So half of that. All right, so let's translate this into a problem here. Let's look at the table. All right, let's look at the table here. So the amount invested in stocks was X. The amount invested in the bonds is 18,000 minus X. All righty. The total has to be $18,000. Now, let's read it. The total amount invested in bonds, which is 18,000 minus X, by the way, equals half of what was invested in stocks. So you had whatever was left, which was 18,000 minus X, which was half of what you had in stocks. Half of stocks, half of X. 1/2 X. Okay, translates to equals. Okay, the key is that first one. How much was invested at bonds? Well, a lot of people want to say why, because you don't know either one of them. That's true. You don't know either one of them, but you can't use the 2 letters in the same problem because you can't solve for either one of them and get a numerical value. But so you have to find the relationship between the 2. So 18,000 minus X is 1, and the other one was X. Now there was another connection. What the number in bonds was half that. So the number in bonds, which is 18,000 minus X, is equals to 1/2 of what was invested in stocks. So that makes us an equation. That's our model. That's our model right there. 18,000 minus X equals 1/2 X. So our job is to solve this equation for X. And so here we go. Step 4. We're on step 4. This is always a good sign. So 18,000 minus X equals 1/2 X. Alrighty. So let's do it. So we add the X to the right side and we get 3/2 X. Now there's a couple of ways you could solve this. When this author decided to multiply both sides by 2/3, you could take it in a couple of swipes. You could multiply by 2, then divide by 3 if you like. But they took care of it in one motion by multiplying by the reciprocal of 3/2, which is 2/3, and it cancels the X right away. So if you watch 2/3 of 18,000, that's X equals 12,000. Now, here's where a lot of people will be, I'm satisfied. X equals 12,000, and they circle the answer. They move on to the next problem. And then they wonder why they lose points. Alrighty? Now, here's where you got to put it in words what you're doing. Okay? So 12,000 was invested in stocks, and 18,000 minus 12,000, which is 6,000, was the amount that was invested in bonds. Okay? So if you notice, the 6,000 and the 12,000 adds up to 18,000, but more than that. Check to make sure your answer is right. So they do add up to 18,000, but notice also the amount in bonds, 6,000, is half of what was done in stocks, 12,000. 6,000 is half of 12,000. So all of it makes sense. They both add up to $18,000, and one is half of the other. So, alrighty? Alrighty. So that concludes this video. If you have any questions on it, and you're going to have questions on other applications, I'm pretty sure. That's why you watch the author videos. They give you a few more application type problems that you want to look at. That may not even be enough there. Okay, I'm just letting you know this is one of the sections that does cause most grief. Because it's applications and there's words, and that you have to read and you have to translate into. So you only get good at it by watching other people do it, but more importantly, do it yourself. They don't come fast. They do take a little bit of time. Nobody is born being able to do these things super duper fast. You get good at them by applications, and you work on them, and you work on them, and you work on them, and more practice. And finally you do get them. But there's always a set pattern of how to do it. But the most important thing is reading it 2 or 3 times and identifying the variables, setting up that model, and then it's downhill from there. Okay? So again, have any questions, let me know, and you have a good day.